Solve problem on inventory model 4A with probabilistic demand for which continuous demand, setup cost 0, stock levels discrete and lead time 0 by using important formula. Given question, the probability distribution of monthly sales of a certain item is as follows. Table is given for monthly sales and probability. The cost of holding inventory is rupees 8 per unit per month. A stock of 5 items is maintained at the start of each month. If the shortage cost is proportional to both time and quantity short, find the imputed cost of shortage of unit item for unit time.
To solve the problem, let us understand the inventory model 4A. Inventory model 4 is under the model with price break and probabilistic demand. For model 4A, continuous demand, setup cost 0, stock level discrete and lead time 0. Now instead of instantaneous demand, here is continuous demand, and instead of continuous stock level, here is the discrete stock level. Now which formula we have to use? So we have to use here summation of r is equal to 0 to Im minus 1 PR plus Im minus half summation of r is equal to Im to infinity PR by r less than C2 divided by C1 plus C2 less than summation of r is equal to 0 to Im PR plus Im plus half summation of r is equal to Im plus 1 to infinity PR by r. So this is the formula. Now if we compare the left hand side and right hand side for this C2 divided by C1 plus C2, then what is the difference? So here r is equal to 0 to Im minus 1. So this is the range. But here r is equal to 0 to Im. That range we have to take. Now here Im minus half. So instead of minus sign we have to take Im plus half. And also for this range, that is r is equal to Im to infinity, we have to take r is equal to Im plus 1 to infinity. Otherwise the formula is same. So what is this r? So r we know that is the demand rate. So what is this Im? So Im is the maximum inventory level. Now this cost of C1 and C2, we have to take C1 as an inventory carrying cost or inventory holding cost, and C2 is the shortage cost that we have to refer. Now what is this PR? So probability of the demand rate R. So because of the discrete stock level, we have to use this PR. So when the stock level is continuous, then we have to use the probability density function, but here stock level is discrete and that's why we will use here as a PR. Now we will move to the given data. Optimum inventory is given. So optimum inventory, that is Im, 5 units is mentioned in question. Holding cost C1 rupees 8 per unit per month. Range of monthly sales 0 to 8. Now range of the sales, that is we can also say range of demand, is mentioned here. R is equal to 0 to Im minus 1 and R is equal to Im to infinity. So infinity, that means this range we can take up to infinity, but here the maximum level is given 8. So instead of infinity we have to use here 8. Now probability is also mentioned in the question in the form of table, that is P0 0.01, that is for this 0 month. For the first month it is 0.01. So this probability P1 is 0.01, P2 0.25, P3 0.30, P4 0.23, P5 0.08, P6 0.05, P7 0.03 and P8 0.01. Now we have to compare what is the shortage cost, that we have to find out the range of this shortage cost C2. So how to find out this range? So we have to first use this left hand side formula and then we will calculate the value of C2. Then we have to use this right hand side formula and then we have to calculate the C2. And this C2 is in between these two values and then we will get the range of the shortage cost C2. Now main important thing is that we have to put the value. So I will take here summation of r is equal to 0, that is 0 to Im minus 1, that is 5 minus 1, 4, PR. So PR plus Im minus half, that is 5 minus half, summation of R is equal to Im, that is 5 up to infinity, but here range is given up to 8. PR by R, PR by R, which is less than. So now we will take here is equal to, because we will use only this value, this for this left hand side formula, that is C2 divided by C1 plus C2. Now how to solve this? So here PR we have to take from 0 to 4, and we have to add, because here is the summation sign. So how to take P0 plus P1 plus P2 plus P3 plus P4 plus 5 minus half. So 5 minus half, that is 5 minus 0.5, that is 4.5. Now for this summation we have to always take the bracket. So I will take here bracket. Now PR by R, but R is from 5 to 8. So first I will take here 5. So PR, that is P5 divided by R, that is 5. Plus now P6 divided by 6 plus P7 divided by 7 plus P8 divided by 8. So we have to finish up to this, because range is from 5 to 8, which is equal to C2 divided by C1. C1 is 8 plus C2. Now we will simply put the value. So what is P0? It is 0.01 plus 0.04 plus 0.25 plus 0.30 plus 0.23. So we have to first solve this bracket, simply make the addition, plus now 4.5 is outside the bracket, so we have to solve this bracket. So P5 by 5, that is 0.08 by 5. So we have to first find out this answer with the help of calculator, plus P6 by 6, that is 0.05 by 6 plus 0.03 by 7 plus 0.01 by 8. So we have to first calculate this, and then we have to add each value, and after solving this bracket we have to multiply with 4.5, and then to the right hand side we will write here C2 divided by 8 plus C2. Calculated value of C2 is rupees 260. Now we will consider this right hand side part. So we will consider here R is equal to 0 to Im, that is 5 PR plus 5 plus half. R is equal to 5 plus 1, that is 6 to 8 PR by R. And we will take is equal to sign C2 divided by C1 plus C2. Now we will consider here R is equal to 0 to 5 PR. So we have to add this probability from 0 to 5, that is P0 plus P1 plus P2 plus P3 plus P4 plus P5. Bracket complete, plus now here 5 plus half, that is 11 by 2. Now in this the second bracket we will take this summation PR by R, and R from 6 to 8, that is P6 by 6 plus P7 by 7 plus P8 by 8, and on right hand side C2 divided by 8 plus C2. Now when we put all the values from P0 to P5 as well as here P6, that is 0.05 by 6 plus 0.03 by 7 plus 0.01 by 8. So we have to solve this bracket first, then we have to multiply with 11 by 2. And when we solve this, we will get C2 is equal to rupees 570.25. So what is the shortage cost? So shortage cost is in the range of rupees 216 is less than C2 is less than 570.25. So this is the range. So value of C2 is in between 216 and 570 rupees.
Solve problem on inventory model 4B with probabilistic demand, for which continuous demand, setup cost 0, continuous stock levels, lead time 0 by using important formulas. Given question, let the probability density of demand of a certain item during a week be f of x is equal to 0.1, where 0 is less than or equal to x is less than or equal to 10. f of x is equal to 0 otherwise. This demand is assumed to occur with a uniform pattern over a week. Let the unit carrying cost of the item in inventory be rupees 2 per week and unit shortage cost be rupees 8 per week. How will you determine the optimal order level of the inventory? This question was asked Agra M. Stat 1973.
To solve problem, let us understand inventory model 4b. Inventory model 4 is under model with price break and probabilistic demand. For model 4b, continuous demand, setup cost 0, stock level continuous and lead time 0. So because of stock level continuous, we have to use here the probability density function. So here is the formula: integration of 0 to IMO f of r dr plus integration of IMO to infinity Im f of r by r dr is equal to C2 divided by C1 plus C2. While C1 is inventory carrying cost and C2 is the shortage cost. Now what is this Im? That is the optimal inventory level. Now in this question we have to find out what is this optimal inventory level. Now let us understand the given data. So f of x is given 0.1 and the range of x is given in between 0 is less than or equal to x is less than or equal to 10. Inventory carrying cost C1 is rupees 2 per unit per week. Shortage cost C2 rupees 8 per unit per week. Now we have to find out what is the optimal inventory level Im. So we will rewrite this formula because in the question instead of r here x is mentioned. So how I can rewrite? So I will rewrite here integration of 0 to IMO f of x dx plus integration of IMO to infinity Im f of x by x, because here instead of r we have to consider x, dx is equal to C2 divided by C1 plus C2. Now we will put the value. So we have to find out this value of Im. So how I can write? So f of x is equal to given 0.1. So I will write integration of 0 to Im 0.1 dx plus integration of Im to infinity. Now instead of infinity, range of x is given. The minimum range is 0 and maximum range is 10. So we can refer here value up to infinity, but for this question this range is mentioned, so we have to take here as a 10. So Im to 10 into Im, here f of x, that is 0.1 by x dx is equal to C2, that is 8 divided by 2 plus 8. Now we will solve. So how to solve this first integration? So here 0.1 dx, that is 0.1x. So I will write 0.1x and I will give the limits from 0 to Im plus. How to solve this second integration? Now this integration, here x is variable, that is 1 by x. We can write here integration of 1 by x dx, because this 0.1 and Im is constant, so we have to take outside the bracket. So for the integration of 1 by x dx, that is nothing but log x. So I will write log x and we will give the limits from Im to 10, and on the right hand side if we calculate we will get 0.8. Now it is simple. So we will put instead of x, that is Im, and instead of x 0 by taking negative sign. So here 0.1 Im minus 0.1 into 0, that is 0. So I will just write 0.1 Im plus. Now here 0.1 into Im is constant term, so we have to write as it is. Now in bracket we have to take log of 10 minus log of Im, because this is the range, is equal to 0.8. Now we will simplify this. So if we observe, here is 0.1, 0.1 and here is 0.8. Now if we calculate on both sides with 10, then here it will become 1 Im. So I can write here only Im plus here 1 Im, that is Im Now what is the value of log of 10? That is 2.3. So I will write Im into 2.3. Now I will multiply this Im inside the bracket. So minus Im into log of Im, which is equal to 8, because we have to multiply both sides with 10. Now again we will simplify this. So here Im plus 2.3 Im, that is here coefficient is 1, that is 1 plus 2.3, that is 3.3 Im. So we have to solve this first part. Now for second part, here log is there, so minus Im log Im we will keep as it is, which is equal to 8. Now how to solve this? So by trial and error method we have to check for different values of Im. And if we take the value of Im is equal to 4.5, then this equation is getting satisfied. So value of Im is equal to 4.5, and this is the optimum inventory level.